Well, it's Australian summer, so it's time for videos with an air conditioning in the background. However, it was snowing in the mountains yesterday, so who knows what's going on. In any case, my neighbour's car wouldn't start, so we did the Immobilizer delete. A whole bunch of things have gone wrong with this vehicle, including the solar regulator overcharging his secondary battery to 22 volts and pushing the other battery into cell reversal into minus 1.4 volts, a brand spanking new battery. In any case, after all of that, it wouldn't start and it wouldn't receive signals from the little remote control unit, which I also repaired. So we hunted this thing down, found it and removed it. And interestingly enough, once this plug was out, what we had to do was put a decent hefty wire between the two wires that were originally on that, and the thing fires right up. Not exactly the greatest security system, and this was really obvious and easy to find. So we're removing it, and we're shaming the designers of this for not thinking more creatively. So we're going to open it up and have a look at what's in this. Now, I have a little spatula thing that was gifted to me by Tinkerman Mick, and I have lost it, and I use it for everything, including stuff like this. Anyway, let's have a look at what's going on in here. This is a circuit board, and we have a little microchip here, which I'm pretty sure is a PIC controller with some flash ROM in there. And we have a bunch of different relays. This is the Tyco relay. This, I'm pretty sure, is connected to this, which is the 433 megahertz receiver module. And that clicks this relay to acknowledge to the rest of the circuit, namely this guy, that the immobilizer button's been pushed. So that's good. Now we have one of these is connected to indicators, the other one is connected to something else, I believe maybe the horn, or the horn relay in series. And this is the ignition relay. And I have to say, I put my clip leads across these two and the thing melted the clip lead. So it's switching probably the full solenoid current across these two pins here, which is a little worrying. But I would have thought a better solution was involved. And we can see here, these two thick tracks are to the switching contacts on that relay. So we can straight away look at the back of this board and determine that yes, those two pins are meant to be bridged in some situations. So bridging those is not unlikely, and given that they're on standard spade terminals, it is really easy to just rip these two wires off, bridge them together, pull this plug out and everything starts. So I guess it wasn't as hard to remove as some of them. We can see here the other two relays. This is the common, they have a normally open and a normally closed. That's easy to see. There are a whole host of other wires on this that I'd have to take a while to examine. But there is, I think, some multiple ignition ones, and I think there's a bunch of other things it's connected to make tracking it down difficult. Although, there was a red flashing light plugged into this. And all I had to do was find the red flashing light on the dash and follow the cables back, and lo and behold, I found this. So it would have been better if there was no red flashing light. And there's these little contacts here which I assume might be programming, or they show as a test port. So that is interesting. Let's view up on this. So this is definitely a test port. Looks like it's been hot at some point or corroded. They've had some contacts on it to try and test things out. So and that might be sort of SPI or I2C, I2C I think is the name for it, as the protocol to program that, or it could be just plain old RS-232. We do see some other little packages in here, but I think this might be RS-232 to something else interpreter, or it might be a quad op amp or something. Might be quad op amp because it's switching relays. So I'd say that's they're using. Let's have a look here through the viewfinder. They are using at least one, two of those outputs, possibly three. So that would be for all three relays. There's a linear regulator down here, and that's not too bad. So look, the design of the board isn't too bad, but it's really conspicuous, and conceptually you could do better. So generally what goes wrong in these four drives, I see people put these immobilizers in them, they're really quick and easy to remove. The one thing is nothing is dependent on this port, so when you pull this connector off, everything works just fine. If you had just a nice little series connection in this that's in line with maybe say the ignition switch or something, So when you pull this out, the ignition switch doesn't work. That would be 100% more secure, because I guarantee if I was trying to hotwire a car on the side of the road and I rip this plug out and the thing doesn't start, I'm not going to chase wires on the side of the road. I'm going to leave it for later on so we can get it back to the workshop. But like this one, if I pop this plug, bridge these pins, and the thing starts, Bob's your uncle, this is getting tossed out the window on the way home. So yeah, we really need to think a little bit better about immobilizers. So I would be interested to actually read the system off this. I might at some date, if I can really be bothered, and it probably won't happen, but get an RS232 onto this and try and read that off there. But most of these are usually programmed one way. They're done in a binary straight into it, so once it's in as a binary format, you've got to know what program it was programmed in to decompile it. But yes, this is the PB3800 revision 4. I am going to find some schematics so that we have some idea what this was originally attached to, so we can fix it later on. But for the time being, he's running, he's back on the road, he can go and get food and shopping and survive, which is the primary thing. So, quickie little one, but we'll see you again later on with something more interesting.